Okay, in this video series, I am going to try and answer the common interview question, what happens when you type www.google.com into your browser's URL bar and hit enter? This is an extremely popular interview question, and it's popular for a couple of reasons. The first reason it's popular is because it's about something that tons of companies actually deal with, networking. You know, if you're a web company of any sort, which basically is like asking if you're a company these days, then people are using their browsers to interact with your website, and your software engineers are programming either servers or web applications, but whatever they're programming, it probably has something to do with networking. Okay? Another reason this is a popular programming interview question is because it's very broad and open-ended, and it gives interviewees a lot of chances to either describe things that they're very confident about, you know, and go on lots of little different tangents within the, as we'll see, the very broad range of possible answers to this question. And it also offers a good way for, you know, seasoned interviewers to gauge the skills and level of networking knowledge of the interviewees. Okay, so for an example of what I mean, an answer to this question that is correct, but not very detailed, could be, you know, okay, I type www.google.com into my browser's URL bar. That causes an HTTP request to be sent to a Google server somewhere. So this is an HTTP request. And Google then responds with an HTTP response. And that response contains the HTML for Google's homepage. Subsequent requests might be made to, say, fetch the JavaScript or the CSS sheets that are also part of Google's homepage, and those subsequent requests would look basically the same. Okay, that answer is correct. This is definitely one aspect of what happens when I type www.google.com into my browser's URL bar, but as we'll see in the rest of this series, it is not even close to exhaustive, and this video series will also not quite be exhaustive. There's so much we can study about networking, and really a lot of it happens, even when I just do something as simple as request Google's homepage. Okay, so in the rest of this series, we're going to look at this simple interaction and make it a lot more complex. But before we do that, I kind of want to tell you what the goals for the rest of this series are. And the primary goal is to teach you all about networking protocols and how, you know, different layers of the network work differently. So, we are not going to spend a lot of time talking about what are commonly considered the two bottom layers of the network, and put a little dotted line. This is the link layer and the physical layer. These two levels of abstraction deal with the physical layer is physics. This is the question of how do I send, you know, electrical or radio wave signals across physical media, so across a copper wire, or, you know, light across a fiber optic cable, or radio waves through the air. How do I use those signals? How do I create and receive those signals? And the link layer is about, okay, how do I take a message like hello, turn it into some physical waveform like blasts of electricity or radio waves, and then also how do I, on the other end of that, receive some physical energy, you know, electricity or light or radio waves, and turn that back into the message hello. So we're not going to talk too much about these two layers, although they are fascinating and interesting, super cool. We are going to talk about the other three. And in the OSI 7-layer model, this top layer is actually 3 layers. You don't need to worry about that for now. We are going to talk about the network layer, which is mostly involving answering the question, okay, I have me and a Google server, but this whole bit of the interaction here, this transmission, this actually happens over a real network that involves lots and lots of computers. So, I'm over here typing on my laptop, and that goes to a router or a modem, and that goes to my local telephone wire, outside my house with like a little Comcast box on it. And this goes into Comcast's network infrastructure, which is pretty opaque to me. There might be many, many computers and routers and lots of physical infrastructure, and this connects to maybe Verizon, because Google is paying Verizon in this example, and then finally I get to Google. Okay, so knowing that there is an actual physical network of connections that must physically connect me to this Google server, how do I efficiently transmit information from me bound for Google through this, what is now an incredibly broad global network of connected computers? Okay? The transport layer, which says, okay, assuming I can use some physical media and send messages through it, encode and decode messages over physical media, and assuming that there's a network that exists and I can cause my traffic to travel efficiently through this network and arrive at its destination, how should the two computers, me and Google's server in this example, how should we send messages in so that we don't overburden the network? And should we encrypt our messages according to some scheme? These are questions that can be answered at the transport layer. So we have to use the network responsibly or not. Some transport layer protocols will not have any kind of congestion control mechanisms or, try and use the resources so that everyone can share them properly. But there are lots of questions to answer there. Knowing that I have this network, how should these two computers define their communication to best utilize this network? And then finally, there is the application layer, where, okay, assuming all the stuff I already said, and now we want to know how should these two applications communicate. So, for example, our browser and this web server have to speak HTTP in order to communicate messages that both parties can understand. And we understand, if we're a Google server that's returning HTML inside of an HTTP response, we know how the browser will then take that HTTP response, parse it, and then deal with the resulting, say, HTML that will be included in this response in this specific instance. Okay, so the goal with this series is to take this seemingly simple question and dive into a lot more of the details about how things work under the hood.